Hey everybody, this is Garrett from Earth and Time, and welcome to Snow Canyon State Park, just outside of St. George, Utah, in the southwestern portion of the state. This is known as a Mini-Zion National Park. If you ever come this way, it's definitely worth the visit. Let's go check out some of the geology here and some of the sites. Here's a bit about the cost for coming into Snow Canyon. So it's $10 for a resident, $15 for a non-resident, up to 8 people. And they do have passes that you can get. They're year-long state park passes. I've moved up the road just a little bit, and what I want to show is some of the stratigraphy here, or the layers of the rocks in Snow Canyon State Park. And most of it's made up of what's known as the Navajo sandstone, but on the southern end where you enter at, which you can see where I entered and came in over this direction, you can see out towards St. George, Utah out there, there's a transition from what's known as the Kayenta here in this lower slope section, where you can see actually slopes with some small cliffs in here, going up into what is more of a massive sandstone. So this is the Navajo sandstone that we start picking up as we look off towards the north, and you'll actually see some big cliffs of it out in the distance. If we look going towards the southeast, you can see the same relationship. So you can see the Kayentas at the bottom here, and then going into the massive Navajo sandstone, which are a bunch of ancient sand dunes. And we saw these as well at Capitol Reef National Park. So imagine a lot of southern Utah, parts of Arizona, Nevada, as basically like a Sahara desert during the Jurassic, so the middle time of the dinosaurs. And as I pan looking at the Navajo sandstone, one thing I'll point out is as you get way off in the distance, you'll see the Navajo sandstone actually turns white. And we'll talk about that. And that's actually the younger section of the Navajo sandstone. So as we go north, we're actually getting younger in stratigraphy. And there's one other stratigraphic unit we should talk about, and those are the basalts that are here. So these are lava flows that erupted about 30,000 years ago from the north end of the park. We're going to go take a look at the volcano where these lavas erupted from, and we can walk right up to it. One of the first sites and hikes you get to is called Jenny's Canyon, and it's a pretty short hike that takes you into one of these fins or one of these slot canyons back around the corner here, and I'll take you down there so we can see what one of those look like. Snow Canyon is also a story about recycling. And what's being recycled here is the sand. So this is the sand that's been eroded off of these sandstone cliffs from the ancient Saharan type desert during the Jurassic. And as it erodes, it becomes sand again. And in one area of the park, it actually becomes sand dunes again. And we'll go take a look at those along our way. But first, I want to take you inside Jenny Canyon so we can talk about some of the formations that we see here and what's creating those. As I continue on the trail, I want to point out one of these fractures that we can see here in the Navajo sandstone. So one of the popular activities here in southern Utah is going and hiking slot canyons. And those slot canyons are created by a combination of things. One is there are naturally fractures within the Navajo sandstone. And how come those fractures are there? Well, we're on the edge of the Colorado Plateau and the Basin Range. And because of that, you have two things happening in this region. One, you have the uplift of the Colorado Plateau, which is famous for things like Monument Valley, the Grand Canyon. And two, you have faulting from the Basin Range. So what's happening is this whole area is being uplifted, and the overlying stratigraphy is being eroded off. And as that happens, these rocks come to the surface fairly rapidly, and they actually create a series of fractures. Those fractures become conduits or ways for water and wind to start eroding down through these massive units, like we see behind me where you can see some of the debris coming down. And these lead to those slot canyons. We call these fractures, and these fractures can be quite large, and some of them can even end up slipping or becoming faults themselves. Let's go take a closer look at one of these slot canyons. So continue on the trail, you get to a point where you can go to Jenny's Overlook and Jenny's Canyon, and we're going to go towards Jenny's Canyon, which is going that way through one of these slot canyons. So as I walk through this slot canyon, a couple things become apparent. One is there's a tree holding on here, and actually it's doing pretty good in here, probably protected from some of the heat here in southern Utah. The other thing we can see is these are big cliffs. So these are, well over at least 50 meters tall or 150 feet. These may be even closing in on 100 meters tall. It's a really tall area, and it gets very narrow. So you can see me for scale here within this canyon, or within the slot canyon. And you can take a look behind me and see what one of these looks like. Pretty spectacular, and a really unique place to come visit. And one of the things that makes southern Utah so interesting, and the Navajo sandstone so interesting, there's a series of these slot canyons all over this region. I mentioned Zion National Park, but there's some above St. George as well, up in what's known as Sugarloaf or Pioneer Park. There's some slot canyons you can hike through there. There's other ones in other areas of the region. I've come to the end of the slot canyon, and there's little birds in here, so I don't want to disturb them too much. Hi, little birds. And there's birds living in here. I know there's bats that live in here as well. But you can get an idea of what one of these slot canyons look like. And as I turn around, you can see what it looks like going out. As far as geology goes, one thing you can see is where the fracture has developed, going right up there. And actually, there's been some movement on that. And why do I say that? So this actually has probably become a fault zone. And the reason I say that is you can see how beaten up the rock is here, and there's a bunch of fractures coming through here until you get to the solid rock on this side, and I turn around and you get to solid rock on this side. So that suggests there's been some movement along this zone. So this would be like a fault zone or fault line in here, although there's probably not a lot of movement. Again, it probably started off as a fracture, and they do get earthquakes in this area, so there could have been some earthquakes or some minor movement along this fracture, which made it into a fault zone. Pretty cool. So why is this area known as Jenny Canyon and Jenny Overlook? There was a young woman who was hiking and rock climbing here who passed away in the process of doing that here in this area. So they set this up as a memorial for her, this trail and this overlook. I ask, if you come up here, please be respectful of this area. Take a moment of silence if you decide to, but please be respectful of this area, because this is a memorial to Jenny. And I would say not just to Jenny, but to others who lost their lives in pursuit of doing things they love and they're passionate about, in places they're passionate about and they love. So, all right, let's go ahead. I know that was a somber note. Let's go ahead and move on up the road and learn a little bit more about the petrified dunes here. And here are those modern sand dunes that you can see behind me here. Now, these are all due to the erosion of the Navajo sandstone. In fact, they even keep the kind of reddish or pinkish hue that you see. Now, what's causing that? Well, it turns out there's a lot of hematite cement in this. So it's an iron cement that helps lithify and solidify these rocks. This is a wonderful spot to see how the earth recycles itself, right? Ancient sand dunes to the modern sand dunes. Now, these sand dunes aren't huge. They are in this restricted basin. So you'll see there's one side of Snow Canyon. Here's the other side of Snow Canyons. At its first extent, it's probably 500 meters across, or about 500 yards. You get up here and it's probably closer to about 300 yards or 300 meters across from one side of the canyon to the other. And then you can actually see there's another canyon behind here. That's another one of these fingers where erosion is taking place going towards the north. These sand dunes are fun to come play in. When I was younger, we used to come here and we just lay on our sides and tumble down these things. And needless to say, you got sand in every part of everything. But it's a lot of fun to come back here and visit and see the modern processes of creating a sand dune and actually seeing where the source material is from. I've stopped at the Petrified Dunes trailhead. As I mentioned before, what's making up the Navajo sandstone here, which is all the red and the white sandstone we see behind us, is ancient sand dunes. So as I'm walking down the trail, off on the right and the left-hand side, there are a bunch of these 30,000-year-old lava flows that are coming down through here. And this hike, the Petrified Dunes hike, is probably, in my experience, the most popular hike in the park. The second most popular, or maybe now it's the most popular, is they have one called lava tubes, where you can actually hike through these lava beds, and there's actually a lava tunnel. And it's really cool to go down there. You need a flashlight to get down there and explore. It's a little farther than I have time for today, but if you come out here, research the lava tubes hike and go check it out. There is a fork here from the Lava Flow Trail and the Butterfly Trail, which are both very beautiful. I believe the Lava Flow Trail is the one that will take you to the lava tubes, and then the Petrified Dune Trail is the direction we're going to go, because I want to go show you some of the amazing shapes you get out of these cross beds within the Navajo sandstone. So now I'm going from the sandy pathway onto the rocks and the Navajo sandstone. And what's making up this topography that we see, or the shapes that we see, is erosion along these cross beds, which creates this amazing texture. And if any of you ever seen the pictures from Antelope Canyon, what they call the, is it called the swell, the Great Swell, which shows these yellow and red lines going down through the canyon. This is the same idea here, where you can actually get erosion of these cross beds, which gives you this really neat texture and topography. Fantastic place to come take some amazing pictures, especially in the right light conditions. And it's so cool walking up these. Look, it's like stairs all the way up to the top of this ancient petrified sand dune. Now what's really cool is you can actually see the different layers between the different migrating sand dunes. So this would have been one dune, and here you'll see there's a color change. This would have been a change, or the basal area between one sand dune and another, and then we can see the other sand dune that's being eroded out. So you can start looking for these cross-cutting relationships to get an idea of which sand dune's older, right? The one down here is getting cut by this one on top, but also get an idea about the direction the wind is blowing. And so what geologists can do is they can take a look at this and look at the directions of the crossbeds and get an idea what direction these dunes were traveling when they were being deposited. Because we can go look at modern day sand dunes and see how they work. As somebody who loves beauty, this is amazing. It's fantastic. And there's almost nobody else out here right now. So I have a lot of this park all to myself. I'm out here in July. It is warm, but I'm here early in the morning, so it's actually quite beautiful. But the other thing I want to point out is I was talking about how we can understand how these flow. And so what we can do is we can look at the dipping direction of these crossbeds like we can see here, and I can tell you that these things were migrating going that direction, right? So these would have been the steeper faces of the dune field. So dunes come up and then they get a steeper face, and what's left as the dune field migrates, the more gentle slope is actually eroded out, and that sand has moved forward and tumbles down the front face of the sand dunes. So I can tell you by looking at this face of rock that this sand dune was migrating in that direction, which is pretty cool to be able to do that. So one of the things I love about geology is that we get to be like Sherlock Holmes. We get to be like forensic scientists of the earth and really think about what was happening during the time of deposition here based on the clues that we see. One of the things that's precious here is water. And when you get on top of some of these sand dunes or petrified sand dunes, there's these little areas where water can pool in due to erosion, and it's eroded down through these sections. And you'll see there's actually trees that develop here. I actually just saw some chipmunks running around up here. So life lives in these little islands on top of these rock formations, and you'll see a whole bunch of these trees popping up here. So this allows life to live out here in this harsh desert environment. Plus maybe they just like the views. I know I do. A question comes up all the time of why is it called Snow Canyon? Do they get a lot of snow there? Well, they do get some snow here. Or is it because parts of the Navajo sandstone are bleached white? No, it's not because of that either. It's because there were two people named Snow that settled in this area, and they named it after those early pioneers that lived here. So that's where the name Snow Canyon Park comes from. If I look across the ridge, you can see my shadow over there. Way down there's my shadow. We can see more of these crossbed relationships coming through, and this is a great spot to see those relationships. And you can see how tall and how much sand must have been in here. I mean, we can see the cliffs way behind us, which are probably well over, hundreds of meters, hundreds and hundreds of yards above us. You know, that's maybe even as high as 800 feet or so above us up there. Pretty spectacular to see. And imagine this much sand just stacking on top of itself and then becoming petrified. From here, we can see some interesting features. One is we can see the basalt that's down there, that's surrounding that knoll or nub of Navajo sandstone off in the distance. We can also see that the Navajo sandstone goes from red here, which has a lot of this hematite cement in it, to white as we go to the north in that direction. Okay, let's go take a look at some of the lava, and let's get up to that volcano and show you where this lava actually came out of 30,000 years ago. As I walk out, I want to talk a little bit more about geologists and geoscientists as forensic scientists as well. So one thing we try to do is we try to pay attention to what's going on around us to get an idea of not just where we're at, but when we're at. And so stratigraphy becomes important for that. And stratigraphy is a story of how the rocks were laid down through time and relative to one another. One thing that happens here, if you ever come out, is the rock layers get younger as you get to go to the north. So the older rocks are this way, and the younger rocks are this way, so much so that you actually eventually get up by a place called Pine Valley, which is a beautiful mountain little town up there, worth visiting if you're out in this area. You go up there and you actually get into what's known as the Claron Formation, and the Claron Formation is what makes up Bryce Canyon National Park. It's very thin here, there's not much, but it is much younger than what we're talking about here. So as you move to the north, the rocks start to young. As you move to the south, you actually go down through this section and the rocks get older, like where we started with the Kayenta Formation, which is older than the Navajo sandstone. And then above the Navajo sandstone, we'll get into some Cretaceous rocks up here and eventually into more younger rocks like the Claron Formation. So just something to be aware of, and something that we as geologists or geoscientists try to pay attention to is what direction are the rocks either getting younger or older, and then we can start putting a story together, what was happening through time in each of these regions. Oh, I have to share these. If anybody's ever heard of Moki marbles, these are iron concretions within the sandstone that, because they're more resistive, they stay together and the sandstone around them erodes out and they fall out and they look like little marbles. Before I get to the volcano that's a source of the lava that we see here, or the basalt that we see here, as you move to the north side of the park, you're going to get a lot more of the black rock that you see here, which is that basalt. And this is the lava flow hike, which takes you to those lava tubes. Unfortunately, I'm not going to have time to do that. However, they do have a nice sign here that talks about the eruption here. This is 27,000 years ago. 30,000 years was the dates I saw, but close enough. What's rounding with amongst friends. But they talk about how a lava tube forms here. And a lava tube is formed when the surface of the flowing lava cooled and hardened and solid crust, but the molten lava underneath continued to flow, which leaves basically a tunnel underneath. And this is a nice example that, so because the lava comes out of the volcano, which we're going to go see here shortly, and this is a picture of that. It's a cinder cone. We'll take a look at that up the road. Lava comes down, and as it hardens at the surface, the molten lava underneath it is protected from heating up as much, so it continues to flow out and go farther and farther out. But what you end up with is a series of these tubes or lava caves. So you'll see where I'm at here And you can see it's about a 2.5 mile hike around. So it's a little, again, a little too far from what I can do today, but you can hike out here and there's 2 different tubes you can go into. Bring a flashlight, make sure you have good footing, some good hiking boots, and be careful because basalt is very sharp. I do like that they have this sign here to talk a bit about the volcanics here. And again, you can see all the black rock that's out there, and that's that basalt. And here is the source for all of that lava, the Diamond Valley cinder cone. And we can actually see the wall of lava behind me that was coming out of this. Now, they call this a breached cinder cone. So what's a cinder cone in the first place? Well, there's lots of different types of volcanoes. There's shield volcanoes, stratovolcanoes. We'll talk about a lot of those in other videos. This is known as a cinder cone. So what that means is this was a volcano that came up. It's not huge like Mount St. Helens, which is a stratovolcano, and not like a shield volcano that makes up Hawaii. This is a pretty localized magmatic source, and it basically comes up, gets to the surface, and spits out a bunch of lava. And that lava basically looks like the lava that you have as landscaping, for anybody who's seen landscaping lava. It's basically this same material. In fact, they actually mined part of this volcano, or the cinder cone, for that material here in the area. So what do I mean by breach then? Well, a lot of times cinder cones will just be that. They're sputter cones. They spit out a lot of lava. It doesn't go really far. It's very focused in this area. But sometimes there's enough lava that it actually breaches out of the bottom of it. So as this thing's starting to sputter and explode going up, right, there's enough lava that it pushes out the base of it, or explodes out the base of it, and you have this big lava flow. So we can see the lava flow on this side, and as I turn around, we can see it on the other side working its way down towards Snow Canyon in the distance. If you come here and you want to visit this cinder cone, you can actually hike to the top here, and it's actually outside of Snow Canyon State Park. So you can come here without any fee and come stop and hike up to the top of the cinder cone and actually see a little caldera in there. It's really cool to see. I was told a story once when I was out here that a group of students from one of the local high schools came here and put a bunch of tires in up here and lit them on fire. Now there's a little caldera in there that's, I don't know, maybe 50 feet deep or something, and lighting those tires meant that smoke was coming out of the top of this thing, and it freaked out, for obvious reasons, the local population here in this town of Diamond Valley. And I don't know if that's an urban legend or it was a prank, but I've heard about it at least twice when I've been out here. People talking about some students taking tires up there. This would have been 30, 40 years ago, and lighting them on fire to create the smoke and fool all the people here. So they did have that prank up here where they made it look like smoke was coming out of this cinder cone. Now this cinder cone is most likely long dead. I get asked, because I'm a geologist, how likely are we to have another eruption here? And the answer is I just don't know, because I didn't work this area. From what I can tell, these are most of the cinder cones are getting younger, to this being one of the youngest here of 30,000. There's cinder cones here that are as old as around 1 million years old, or 1.6 million years old in the area. So this appears to be one of the youngest ones. Hopefully this is the last of that magma in this area and we won't see any other eruptions. I will say that this volcanic activity here is younger than what we see at Yellowstone. So there is activity within the greater western US, places like Mammoth, California, and I already mentioned Yellowstone. Okay, so that's a bit about the volcanoes here and about what's generating this 30,000-year-old lava coming out of this Diamond Valley cinder cone. Let's go take one more look within the park, and then we're going to wrap it up. I've stopped at what's known as the White Rock Amphitheater, or we used to call this area Three Ponds, or I think Three Lakes was the other one, or Three Springs. So I'm walking up to the northernmost portion of the park now, where we can see there's a couple of things going on. One, walking in some more of the soft sand, so a nice calf workout. And I can see the white Navajo sandstone up here. And we're going to talk a bit more about why people think the Navajo sandstone is white up here, but it's red, as you can see off in the distance. And as I'm hiking towards the White Rock Amphitheater, you'll see I'm hiking over a bunch of these basalt flows. or lava flows along the way. The volcano we just came from is just over that hill there. So the volcanic flow came down through there, down here, worked its way all the way down, and you can see the volcanics in the distance as well, and all the lava going down towards St. George. I'm now starting to enter into the White Rock Amphitheater area. And you'll just see that compared to where we were earlier, where everything was as vibrant red or red-orange, this really is bleached white throughout this whole section. Quite a contrast from the north end of the park, where I'm at now, from where we came from in the southern end of the park. Just want to take a quick pan up here. You can see how beautiful it is, and this is a pretty short hike. Only took me about 10 minutes to get here from the trailhead. I wanted to come up here not to only show you how beautiful it is, but also talk a bit about the geology. So there's this ongoing question of why are the rocks on the north end of the park all bleached white or all white compared to what we see in the southern end of the park? And there's a couple hypotheses I've heard. One is, as I mentioned before, hematite cement is what creates that red color. So hematite is an iron ore, and the question is, was there just no iron here? And I have a hard time with that one. I would imagine there would be enough iron to at some point color these rocks red as well. And there are places where we can see, and not right here, but we can see streaks of red still in a couple of these spots. So that would suggest that these were dyed red at one point. So I'm not on board with that hypothesis, or at least I think that hypothesis is less likely. But the other hypothesis is really a story about fluids migrating through here. We need to go back in time and think about what this looked like millions of years ago. And what do we know about this area? Well, we're in an area known as the Colorado Plateau, and we know this whole area has been getting slowly uplifted. And with that uplifting means there's been a lot of erosion, so much so that this area was probably buried under at least a mile of sediment, maybe 2. And how do we know that? Well, if we look off in the distance, there's a series of mountains out there, and those are called the Pine Valley Mountains. And those are what are known as a laccolith. So for those of you familiar with the batholith, they are intrusive igneous rocks. And what does that tell me? So that tells me the highest peak up there had to be buried at some depth, maybe even miles there or a mile deep there, compared to what it is today, because this was all deposited deep underground, and now it's exposed and at a much higher point than I am today by thousands of feet. That tells me at one point that this had to be buried at least as deep as that. So what does that mean for this fluid story? Well, when sediments are buried deep, you get hot fluids and you get various types of fluids. Now those fluids can contain minerals like gold or silver or copper, and then they get deposited. Or in the case of some research that was done out in Moab, Utah, they believe the white rocks here are stained because oil migrated through these at one point. And this may have been a paleo or historic oil field 100 million years ago, 50 million years ago, a really long time ago, back when there was a lot more sediment, miles of sediment above us. In Moab, they actually found leftover oil in some of the white rock in the sandstone there, in the Navajo sandstone specifically, which is just like this. And the prevailing thought is when you have hydrocarbons or oil migrating through with water, it'll actually sweep out or mobilize the iron and move it away, leaving bleached rock. Now, the other part of this story that actually makes sense and why I think this is a very plausible hypothesis here is, if you remember, the older rocks are down lower and we've walked up section to younger and younger rocks. So we're in the youngest part of the Navajo sandstone within Snow Canyon State Park. And because of that, if we think about what happens with oil and water, right? Oil floats on water. The same thing happens when these are buried deep. The oil will float up or move its way up because it's buoyant towards the surface of that rock unit. So in this case, it came to the top section of what is the Navajo sandstone, which is why this may be bleached. So we could be looking at here a paleo oil field, but that's a very plausible explanation. Somehow there had to be enough hot water and fluids coming through to mobilize and move all the iron staining out, and an obvious way to do that is through migrating hydrocarbons. Now, it's possible that you can migrate just hot water through this as well and take out the iron here in what's a reducing front or reduction front. Just often we see those relationships with hydrocarbons or oil, and because of the work in Moab that they're actually able to find some of the paleo oil, that's the hypothesis I tend to like the most for why these are bleached here. However, there may be some other ideas out there, and that's the beauty of being a scientist and a geologist, is we want to look at all those different ideas and see which ones fit the most observations. As I was stating earlier, back when we were on petrified sand dunes, is being a geoscientist or geologist really is like being a forensic earth scientist, or like being Sherlock Holmes, or for those of you who watch Netflix, Enola Holmes, great show. And we're trying to solve mysteries, if you will. What are these mysteries the earth has, and what are the clues it's given us? Well, in this case, we have two different types of sandstone. We have a red sandstone in the south and a white one to the north. Why could that be? Why is there that difference? There must be a reason. And so I talked about those two hypotheses associated with that. It's one of the reasons I love being a geoscientist or a geologist, is that I'm always trying to learn, and I'm always trying to figure out these mysteries. All right, with that being said, we're going to go to the southern end of the park, and I think we're about done here at Snow Canyon State Park. I've actually got to hit the road again and go off to some more adventures that I'll take you on. Thank you all for joining me today to learn about the geology of Snow Canyon State Park. I hope you all get a chance to come visit this place. It is beautiful and amazing. It really is breathtakingly beautiful here. With that being said, if you enjoyed this video, please remember to give it a thumbs up. If you haven't already, please subscribe to my channel. Keep up on all my adventures on geology and history, and make sure you hit that bell for notification to keep up on all the latest episodes. Thank you again for joining me, and take care.